Welcome back, YouTube. We are now open the Vivado software. We'll go ahead with the first step, which is to create a Vivado project. We will name the project Lab 6 and targeting ZBoard Sync Evaluation and Development Kit and using VHDL language. The first step we need to do is to go to the Create New Project. A tutorial will be presented. Click Next on the first step. The project name should be Lab 6. And you save it wherever you want. I'll save it in C Labs. Please make sure that Create Project Subdirectory is checked, and then click Next. In this window, just make sure that RTL project is selected, and then click Next. In this window, the target language should be VHDL. Click Next. In the two next windows, just click Next. We will specify board, and the board vendor should be em.avnet.com. The library should be sync, and the name should be Z. We will be presented with two different evaluation and development kit. It's the version C and the version D. It doesn't matter which one you choose, I'll select C. Click Next, and then Finished. Now, the first thing we'll need to do is to click on Project Settings. Then go to IP and add a repository. The repository is the file that you got from the internet. It's located in lab source, lab 6, and then fear IP. Select fear IP and then select. Please note that it's now written fear top v10 in this window. Then click OK. We are now ready to go to step 2 of this tutorial, which is to create a hardware system using IP Integrator. We will start by creating a block design. Use System as the design name and press OK. You can see this green message which says that this design is empty. To get started, add IP from the catalog. Press that link. Search for ZY, and you will see that 2 options is available. Select the one that do not have the BFM at the end. Double click on it, and you will see that a block is visible in the design. If you double click on that block, you'll get a lot of options. Go to the MIO configuration. Then expand IO peripherals and application process unit. Please also expand the GPIO, and you will now see that some of these entries has a check mark in front of it. Remove all the check marks except for UART1. And then press OK. You can see that UART1 is the only one that has the check mark. Now you can see a new message here. Designer assistance available. Run block automation. Press that link. And then click Process System 7.1. Press OK on this dialog, and then you can see that DR and fixed IO is added to the design. We are now ready for the third step of this tutorial, which is to add the FIR core to the system 2 times, naming the first one FIR left and the next one FIR right. At the end we will validate the design to confirm that everything is as it should. The first thing we will do is to add an IP. You search for FIR and select the one which is named FIR top v1. double click on it to add it to the design. You can now see that the name of it is FIR Top 1. We want to rename it by click on it and then write FIR_left. Then we will add a new box with the same procedure. Press add IP and then search for FIR and select FIR_top, double click on it, drag it into the design, click on it and rename it to FIR_right. We will then connect the boxes to the processing system. We will start with the left box. You do that by pressing this Run Connection Automation link and press the left. Confirm that dialog box and the left box will be connected to the processing system. You can see it over here. Next we will connect the FIR right box to the system by doing the same. To tidy up this mess, we will just move a bit around on the boxes. We set the FIR right box up there, system in the middle, the left box down here, this up here and that one up down here. This look much better. Next thing we will do is to validate the system. You do that by pressing the tool and then validate design. You can also use F6 as a shortcut. As you can see, the validation was successful and it is no error in this design. Press OK. We are now ready for step 4, which is to create the top level HDL of the embedded system and then generate the bit stream. We start by going to the Source tab and right click on System. Then we select Create HDL Wrapper. You get a message that confirms that the wrapper.vhd has been generated. Press OK. You can now see that we have got an HDL code. Then to generate the bit stream, then we just press this button. You save the project, of course, and then confirm this message. There you go. When it's finished, you will get a message. You want to open the implemented design. Select it and then press OK. There you have the bit stream. And you also get the message whether you would like to leave a feedback. Just click later on that. In step 5, we will export the design to SDK, create the software board support package using the standalone operating system. We will also enable the profiling options. To start SDK, press File, Export, and then Export for SDK. Make a checkmark in front of Launch SDK and then press OK. SDK has launched. Press File, New, and then Board Support Package. Make sure that it's standalone BSP0, that is, it's written in this area, and then press Finish. In the window that pops up, press Standalone, and then change the value of this to True. Then go to CPU Cortex-9 and edit the value of this extra compiler flags so it's PG in the end. Then press OK. In the sixth step of the tutorial, we'll create the application files. We do that by clicking File, New, Application Project. In the project name, we write Lab 6 and check the use the existing standalone BSP0. Then we press Next, selecting the empty application, and then Finish. Then we right-click on Lab 6 and press Import. Here we press Expand the General and select the file system. Click Next and then browse to the Lab 6 file folder. In my case it's saved in the Dropbox. Lab source, sources, and then Lab 6. Okay. Then put a check mark in front of every file except lab6.h. When done, press Finish. There you go. The files are now created and we're finished with step 6. The next step is to run the application on the Z board and profile.